Hello and welcome back to the Inside Java podcast, a podcast about everything Java, brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog, and today's episode is a conversation with Mark Reinhold, Chief Architect of the Java platform, that we recorded behind the scenes at JavaOne 2025. Mark traces the arc from the Cowboy mode during Java's early days, his words, not mine, to the challenges that brought for Java's continued maintenance and evolution, to how modules specifically and integrity by default more generally tackle these challenges and pave the way for another few decades of deliberate stewardship. In between, we touch on applets, the XML and AI hype cycles, why there is no module system, and a few more things that only Mark, with his almost 3 decades of JDK development, can bring to the table. It's story time. Enjoy.
So, Java's 30 years old now, and we learned a lot of things in the early days. I mean, we're still learning things, right? But in the early days, I wasn't there at the very beginning. 1.1 was the first release I worked on, but we were very much in what some people would call cowboy mode, right? we were moving really fast. We were expanding the platform at a rapid rate. We had a variety of different levels of skill in the team. So much that we were trying to do so quickly. Yeah. And in that kind of environment, it's very much like a startup environment. You're trying to get to satisfy the users that you have and get new ones and meet all their needs and understand what their requirements are. You do things fast and you don't necessarily think about the long term because you're just focused on the short term of getting your thing to be adopted.
Yeah, running into long-term problems is already success because that means you survive the short term. Yeah,
exactly. So there we were. The first few releases, we understood that compatibility was important. We did have the Java compatibility test suite and all that, and the specification that we took very seriously because at that time there were a variety of implementations across the industry. But we were sometimes just fast and loose with things. And as time went on, we got to the 1.3, the 1.4 release era, and people started to deploy serious systems on Java. Right. In the early days, it was, it's this cute little thing, runs in a browser, and makes Duke dance around and all that sort of thing. Yeah. Okay, sure. But as we know today, Java running applets in browsers was part of the early vision, and it didn't really work out.
Yeah. Do you think it? I mean, this is probably besides the conversation that we actually want to have. But is it just because I wouldn't call myself young, but I'm like of the age where like Java in browser applets was never more than a toy for me.
Yeah.
Was there ever a time where it was like really contributing to the success of Java, where you would think, because there are certain situations where we now think that it was maybe not the ideal circumstance. For example, the way that Java has like this language is bifurcated between reference types and primitives, but it is understood that back then that was necessary. It kind of like was the only way to go. Do you think applets at some point really contributed to the success of Java, and now that time has just passed? Or do you think Java would be where it is today with just less work if you just never had that idea, or if that idea was never conceived?
I suspect applets helped popularize it. I suspect they helped with adoption. They made people aware that Java was a thing. Okay. And then some people saw, looked at it and realized, that wouldn't be a bad language to write an app server in. Okay. Even though an app server is a very different thing than an applet running in a browser.
So if nothing else, at least they helped market Java.
Yeah.
Okay. Yeah. But they were a serious idea though. They were not invented as a marketing gag. They were like.
Oh no, applets were a very serious idea, and Sun had this partnership with Netscape to get the runtime into Netscape Navigator, and there were a number of users and customers who wrote some serious applets that did like serious business functions or serious interactivity. Yeah. But it was not. I don't to my knowledge, it was never really the norm. It was not very common. Anyway, getting back to the story.
Exactly, yeah.
So
I would have said that, but yes, go.
Right. So around 1.3, 1.4, people started writing what we now call app servers. Serving web requests, intermediating between browsers and databases, and all of that stuff. So when we made changes, we sometimes broke things.
Unheard of.
we sometimes broke things in a way that mattered. So a particular incident that I remember vividly is we were maybe halfway through the development of JDK 5.
Mm-hmm.
And as a cleanup, we removed a bunch of private static fields in the numeric wrapper classes, Java-lang integer, Java-lang float, etc. It's like, these are private static fields.
Yeah.
Who's going to care? We don't need them anymore.
Does it matter what they did? Does it matter what they're there for? Or is it
I'd have to go look. I don't remember what.
Okay, yeah. So it's clearly not that important to the story. Yeah, okay.
Yeah. So we did that. Fortunately, as we do today, we had people testing early access releases, and it turns out removing those private static fields, who knew, broke every app server.
Oof.
Because every app server used a very popular XML library from an open source foundation whose name starts with the letter A. And that XML library, for whatever reason, hacked in using reflection and accessed these private static fields. And so when those fields weren't there, app servers went.
Yeah.
I remember a fairly tense meeting where a bunch of engineers were arguing, no, these are private static fields. We should be able to do what we want.
Yeah, which is a sound argument.
Which is
I probably would have been on that side.
It's not wrong
in that camp.
Yeah, and then others were arguing, no. Look, if we want Java to be successful in the enterprise market, we have to take compatibility seriously, even if it means doing things that we find completely distasteful and from a principled point are just wrong.
Yeah.
So in the end, we held our noses, we put the static fields back in, and that was that. But
you're not the only one experiencing this, and this is one of the reasons why JUnit 4, or rather JUnit 5, was a complete rewrite from JUnit 4. There are a bunch of reasons, not that many though. One of them was they want to go to Java 8. One that's that their extension model wasn't really up. They had a better idea for extension models, but one reason was that JUnit 4 is not only the library that runs your tests, it's also the platform against which IDEs observe your tests.
Yeah.
Same thing happened there. IDEs were reflecting deeply into JUnit to read the current state of, because there was some API missing, and it was easier than to have that talk into the library. So I'm not even saying that IDEs did it wrong, but in the end of the day, it was the same situation. They did internal refactorings that broke, and they also made the decision, well, I mean, what good is the new JUnit version if then all the IDEs stopped working with it properly? So they also had the same situation where they felt like certain parts that should have been internals were calcified and suddenly couldn't move. And this can really block, I mean, probably not the case with integer, but because you probably want, the integer class itself was still public and, part of the API. But for them, it really felt like that meant that certain refactorings were just entirely impossible because things couldn't be moved. And so I think things are often obvious, but I think it's not that uncommon either that these situations crop up even within application development as well, where you have what you consider an internal suddenly becoming somebody else's API.
Yeah. No, that's exactly right. And so that incident and incidents like it around the same time frame were sort of the beginnings of our thinking about what we now call integrity by default. We didn't have that pithy name for it until fairly recently, but we understood that, okay, well, with the language we had at the time, we had no effective way to really encapsulate internals. All we could do was warn people, don't use this.
Yeah. Although it all comes down to set accessible true, right? Like that's basically 95% of the path that these broken.
Sometimes not even that.
Okay.
Right. So there are similar stories around perhaps the most famous non-standard class in the platform, sun.misc.Unsafe.
Right. Yeah. That was the other. Yeah.
Right. So sun.misc.Unsafe. We created that in 1.4. It's a low-level interface to the JVM. It is meant for internal use only. It's an inherently unsafe abstraction that's useful for building better, safer abstractions.
Yeah.
Right. And in the early days, it was used to make reflection a lot faster. Reflection originally was all implemented with all this hairy J and I code. It was horribly slow and hard to maintain. It was also used for the Java util concurrent package. A lot of its primitives were in there. A variety of other things. We used it to speed up AWT with an improved X11 library interface.
That sounds like very disparate use cases. Like, that sounds like a grab bag of
Yeah,
whatever.
it is a grab bag.
Wow. Okay.
I mean, it was even used to speed up Corba for like the 5 people who cared about Corba. Whatever.
Do you have like a line count? Like how large was it before? Because now it's smaller, right? Things got removed already. Because that sounds like, I knew that there's some stuff in there, but I didn't know all the use cases. And as I said, there's some very like disparate use cases. So how large was this class then?
What, sun.misc.Unsafe?
Yeah.
Well, it's just an interface full of native methods, so it's actually not that long.
Oh wait, so there are no implementations in there? See, that's how.
Yeah, I mean,
that's how much I respect
they're all
that.
intrinsified by the JVM.
Okay, that's how much I respect it. I didn't even look into the code. That's why I don't know.
Good man.
Lazy in just the right place. Okay.
Anyway, so sun.misc.Unsafe was there, and we didn't even, we couldn't really. It didn't make a lot of sense to hide it. We did make it a little bit hard to use. You had to go through this little dance that you can find in like 200 different Stack Overflow posts. How to do it? You can get the unsafe singleton object and do unsafe stuff. But it was kind of a double-edged sword. I mean, we put it there for experts. We put it there for ourselves. We put it there for some of our expert collaborators like Doug Lee, who's the guy behind Java util concurrent. Because we trust Doug Lee, right? Mm-hmm. And the fact that sun.misc.Unsafe was accessible from outside made it possible, for example, for Doug and his collaborators to continue to evolve the Java util concurrent package. They could try out new primitives they were thinking of outside the JDK, but sun.misc.Unsafe was there for them to use. Yeah. And so it was a good thing. And quite a number of popular open source projects used sun.misc.Unsafe. I mean, Apache Cassandra used it. Quite a number of others, and so it's this double-edged sword where it was, in a sense, it was good that this was available so that experts in the ecosystem could innovate using primitives that otherwise weren't available. Yeah. It was bad, however, because this was an unsupported API, and as time went on, even though it wasn't part of the platform specification, we maintainers of the JDK, based on our past experience with the numeric wrapper classes, realized, okay, well, this is a de facto standard API, and we have to be very careful with it. Yeah. We can't just refactor it whenever we want. We can't just remove methods that we don't need anymore for the JDK. I
forgot what the name of that law was, which is every publicly observable behavior
Hyrum's law
becomes API. It becomes something that people will rely on. Yeah. Yeah. Okay. So
I mean, I think
Hyrum's law.
Yeah, Hyrum's law. I think Java's done maybe a bit better than some other platforms because we've had this strong tradition of a thorough specification from the beginning. Yeah. So it's always been clear that Java lang string you can count on. Yeah. sun.misc.Unsafe. You're playing with fire. It might burn you. Yeah. Be careful.
I also like how sometimes there's actual engineering work going on in basically working against Hyrum's law, which is specifically I'm thinking of set.off. So these smaller what were they called?
The collection convenience methods.
Exactly. So
factories.
List has an iteration order, so list of ABC is always ABC, but set of ABC should sometimes be BCA. But if you have like these simple wrappers that because set.off just creates, as long as it's like a handful of elements, just creates an array and dumps the things in there. Yeah. But then the iteration order would always be stable. So then people could accidentally start to rely on set.off stable iteration order.
But we actually made that random.
Exactly. That's crazy, right? There's extra code in there that is entirely unnecessary from a functionality perspective that is only there to obfuscate an implementation detail so that people don't actually start to depend on it. Because the one that wasn't also breakage, I think, when in Java 7 or 8.
Hash map iteration order.
That's a thing, but that's not what I'm thinking of. I think reflection changed the order in which it iterated methods within a class. And then it turns out that while your tests should never depend on order, and while your post-construct hibernate methods should never depend on order, they might accidentally, because while reflection API makes no promise in which order it returns stuff, it happened to always be the same order for years. Yeah. So you might accidentally have a dependency between two of these methods without knowing, just because always the reflection API returns in the same way, in the same order. Always the testing framework or Hyrum, whoever, will execute them in the same order. And so, yeah, it's really fascinating how the length to which OpenJDK goes to, at least in some spaces, in some areas, to prevent that from happening by putting in code that is, strictly speaking, as I said, like not even necessary to be there.
Right, but it helps developers write more robust code.
Yeah, exactly. That's what it's about. Yeah.
Yeah. So, right. So, numeric wrapper classes, sun.misc.Unsafe, and
hiding internals.
Hiding internals.
Where this goes.
Yep. So, as time went on, there were more and more of these troublesome APIs that had become de facto standards. Not just sun.misc.Unsafe, but there's a whole bunch of stuff in sun.misc that was there and was just useful, like sun.misc base 64 decoder. Oh yeah, that's useful. That's there. I'll use. Okay, yeah, it's not standard, but whatever, it's there. And we eventually got to a point where there's all this stuff that we weren't maintaining. There were refactorings we wanted to do to move the platform forward, but we either couldn't or they would be much more expensive exercises. And that is a large part of what motivated doing modules in 9. To gain the ability to draw boundaries around things, so that we could hide their internals in an effective manner. We could refactor their internals, to draw boundaries around things and then be able to remove them.
Yeah.
For example, the Java EE modules, which arguably never belonged in SE anyway. Yeah. And by that time, really didn't belong there. Once we had modules, we could say, okay, here are the EE modules. They're deprecated now, and we will remove them in the future, and then they were gone. But even so, we had learned from our experience with the numeric wrapper classes and everything else to do this sort of thing really slowly.
Yeah.
So in 9, the encapsulation boundaries around the JDK internals were there, but they were sort of off by default. You get like one warning on the first one that you used, and over time it took us until 16 to make them encapsulated by default, and then 17 to make them encapsulated, period.
Yeah. Although, just people know, there's still at opens and at exports, so there's still ways to explicitly say, I know what I'm doing, hopefully.
Exactly.
I want to opt out.
Right. But the important principle that we identified when we were working on modules for 9 is that the only person who should be able to make that decision is the owner of the application.
Yeah.
Right. What we don't want is what we had seen so many times, where you've got an application, you've downloaded a bunch of jar files from Maven Central. Yeah. And you give this big complex network, and this jar depends on that jar, depends on that jar, depends on that one, and you've never even heard of this one, but it's using sun.misc.Unsafe.
Yeah. Sounds like left pad.
Or it's using base 64 decoder or some other thing that has been there forever but not supported. We wanted to avoid that. So if you own the application, the entire application, which means you have control over the command line of the Java launcher, you can explicitly request, okay, give the class path or give this module access to JDK internals.
Yeah.
That library itself cannot.
Yeah.
So you will no longer ever be in the situation of, oh my gosh, my application, I upgraded some stuff, my application's dead and I can't figure out why.
Yeah. So that's why it's important, though, when on the move to integrity by default with these command line flags that basically opt out of that people are aware that that's what they're doing. Right. Opting out of this integrity, opting out of some of the promises that Java gives, which is fair if they make an analysis that's helpful for them, and that's what they want to do. I'm somewhat worried that so at the moment, I think it's important to talk about this repeatedly, so developers really generally understand that this is what's happening there, that this command line flag isn't just some innocent way to make it work, that this really means it boxes them into maybe this JDK version or whatever else could happen. Maybe there's some performance optimizations they might not be able to get or something else. So because maybe we can talk about that, these downstream benefits of integrity, but you're not just making it work. It's not just like, I don't know, so like the class path option or like a different logging option. You're changing, or rather you're opening up the JDK in a way that can lead to downstream problems. So it's not just a way to make it work. That's the
that is a critical point. If you use add opens or add exports or whatever on the command line, then you are signing up for risk. Right? If in the next release your application fails, then that's your problem. It's not it's not the JDK's problem if it's failing because you enabled that access. So in parallel with all this, we were deeply aware that a lot of the stuff in, for example, sun.misc.Unsafe, those are important primitives for developers to have access to in a safe way. And so our long-term plan, by the way, and just for people who don't know, sun.misc.Unsafe is still there today. It's in 24. You don't need to do anything more special to get to it than you did in JDK 5 or 4. But we have been executing on a long-term plan to gradually create standard replacements for that functionality. And as those replacements become available, we deprecate and remove that functionality from sun.misc.Unsafe. And eventually sun.misc.Unsafe will be empty. And then we will remove it.
So
but that's still a ways down the road. But var handles were the standard replacements for some important aspects of sun.misc.Unsafe. The other big one was the foreign function memory API from Project Panama.
Yeah, that's why speaking now in JDK 24, the memory access methods are deprecated for removal, because now with FFM API, there's the good replacement for that. I think if I recall correctly, back in the days, you made up 3 buckets where APIs fall in to decide, because as you said, sun.misc.Unsafe is available in the way it is today, without additional command line flags, which is kind of odd, because you think, wait, didn't you just say everything is encapsulated?
Right.
So sun.misc.Unsafe got basically, it's not the only one. I think the base64 encoders and decoders and stuff like that.
No.
Back in the day, wasn't
not the base64 encoders and decoders.
Those were never.
Those were non-critical internal APIs.
Exactly. Go over that.
F261, we had external supported APIs, critical internal APIs, and non-critical internal APIs. The critical internal APIs were sun.misc.Unsafe and just a few others.
Signal handle? I don't even know what that is.
No, not the signal stuff. Sun.misc.Unsafe, there was a couple of classes for serialization because some external serialization frameworks depended on them, and there was no effective way for them to do it on their own, and not much else. And then all the non-critical internal stuff included base64 decoder and
that specifically already had a supported API, by the way. The reason why I'm pretty sure like half the use cases of the internal base64 encoding and decoder were people who haven't checked JavaDoc in the last couple of years and just copy pasted from Stack Overflow, because there were already public replacements available that just not everybody had adopted it. But that fix was also really easy. It's just like a one-line change.
Right. Well, it was more than that, because the public API was a little different. But base64 decoder is kind of a funny story. At the adoption of Java 9, we knew was going to be more difficult than most.
Rocky.
Because not so much because of the introduction of modules. And it turns out most of the pain of upgrading to 9 was not due to the introduction of modules. It was not due to the introduction of encapsulation, which wasn't even on by default. It was due to the removal of non-critical internal APIs.
And the version string, surprisingly.
And the version string. And we knew those were going to be risks. But even today, people like to blame the poor adoption of 9 on the introduction of modules. No, actually.
I agree. That's interesting. It was kind of a gutsy
water
move,
under the bridge.
Right, to basically say, okay, this is going to be a challenge. Let's box all the things. Let's do it all now. Let's rip off the Band-Aid quickly. And or is that a coincidence? Because I feel like...
but we didn't even rip the Band-Aid off quickly, right? It took us until 16.
That's the encapsulation part.
17 to turn on.
Yeah, but we still knew that
it was coming, and you got warnings. In 9,
exactly.
in 9 you got warnings. By default, you'd get one warning on the first encapsulation breakage.
And then you got some APIs, as you said, that were removed and then were the version string, for example. It feels like the version string could have happened at any time. Was it coincidence that it ended up in 9? Was it basically an idea, okay, there's going to be some challenge with updating to 9 anyway. Let's do other things like the version string, which should be benign, but everybody knew
there was definitely a certain amount of that thinking.
It was like, let's just do it now.
Things that we knew we needed to change, and we didn't. We did not want to have several disruptive releases over the next 10 years.
I think it was smart. We already struggled with meaning. Well, back then I didn't work here yet, but still I like modules, so I tried to convince people to use it. Updating past 8, of course you would update. Why wouldn't you? But It was already hard to convince people.
Yeah.
And I think it's good that there's just one of those stressful jumps from 8 to 11. People who went from 11 to 17, specifically from 17 to 21. I mean, depending between 11 and 17, depended how seriously they took the warnings for modules. But those people did take them seriously and prepared. Had 11 to 17 was straightforward, and 17 to 21 even more so. Of course, there are always like niche things.
Sure.
But I think most of the ecosystem observed, hey, we got the hard part behind us now. And I think that was important. I think giving people more than one difficult jump would have maybe cemented the idea that, oof, Java updates are hard now.
Yeah. No, I think that's exactly right, and that was definitely part of our thinking. But anyway, so other benefits of integrity. Talk about encapsulation. So yeah, the ability to refactor internals is definitely one of the big ones.
Mm-hmm.
And for some of the things, especially that we're doing with like Project Valhalla, it's just like this epic. It's Java's epic refactor, we sometimes call it. We're changing all kinds of stuff inside, and if all that stuff was still visible, and people were still using it, it'd be a much harder thing to accomplish. But aside from just maintainability, integrity has other benefits. There, just correctness, right? If you start up your application and you're not enabling any busting of encapsulation boundaries, you can have higher confidence that your code is going to do what you think it's going to do.
Yeah.
Right. There's no random jar file from Maven Central is going to use sun.misc.Unsafe and come rewrite something. It's important for security, obviously. Right. For the release of 9, I worked with our vulnerability team. We did an analysis and realized that of the 6 0 days that have been reported against the JDK in something like the last, I don't know, I forget what it was, 5 or 10 years, 3 of them would have been permitted.
Yeah,
if we had strong encapsulation.
In one of your talks or in one of the JEBs, I recall that number, right? Yeah, good. That's a good point.
Half the 0 days. That's
that's
a big deal.
It's a big chunk.
Yeah, and then finally there's the performance benefit, and this is something that's more theoretical right now, but something the folks on the JVM team have been deeply aware of and annoyed by for now decades, is final doesn't mean final.
Yeah.
Right. Anybody can do set accessible on a final field.
I was going to say it again. It's set accessible's fault. Just like with the encapsulation.
So many things are set accessible's fault.
Just deprecate that one. That seems like the easier. Would have been the easier step apparently.
Yeah, but so that prevents the JIT compiler from constant folding through final fields, and sometimes that sort of constant folding can do a lot of optimization for you.
Yeah, doesn't make? I'm just wondering right now, but I think it does make sense actually, because Java C also does very simple static, very simple constant folding in those situations. Right, I have a private static final int foo equals 3 plus 5.
Oh that's just constant expressions.
Right,
sure.
and if I also reference another, so I have 2 classes, 2 separate compilation units. Mm-hmm. And one of them references a private static final public static final string field over there.
Yeah.
Like, doesn't it? I think doesn't it embed that string here straight away when you reference it? I think it does. Or maybe just with numbers. I know there are situations.
I think it's only with.
Maybe just the arithmetic numbers. We have to look it up.
We'll have to look it up.
But I'm pretty sure.
Here's the JVM spec. Oh.
That is a good point. Yes. By the way, since you're reaching over the table, total sidetrack. What we have here is the Java 1 Java Developer Conference program guide from 20 something, from 2000, It's a very old one. And I flipped through it the other day. I'm not going to find it now. And I saw in here, Birds of a Feather session about something XML related with one Mark Reinhold.
Oh,
There
really?
it is. Adelard, XML data binding Q&A with Mark Reinhold, staff engineer.
Yeah, there you go.
Those are the days.
Yeah, XML was at the peak of its hype cycle, kind of like AI is now.
Oof, that's rough. I would add so you mentioned the different benefits of integrity, and including, as I said, performance is more theoretical right now. I think we're probably speculating on. But
Well, I mean,
sorry,
I probably shouldn't have said that. It's not entirely theoretical because
they're not entirely.
We
but
have done experiments where we tell the compiler, okay, go ahead and trust final fields.
Okay.
And there are measurable performance improvements.
Oh, nice. Okay. I mean, that sounds like something that on a benchmark would be somewhat straightforward to measure. That would be interesting. So if ever somebody in OpenJDK feels bored for an afternoon, maybe we can see some numbers on that. That would be good to know.
Mm-hmm.
So will you in the future, so are there plans to make final more final? I know that there's a new API called Stable Values, which does a few things, but mainly the idea is to have finality for something that is initialized late. But that then is really, really final, just like the record components are really, really final. And I'm going to go out and guess that probably Valhalla's value types fields are also really, really final.
They are so final you wouldn't believe how final those fields are.
Is there any way to backport that? Like, could you give me a flag where I say I want final to mean final, and screw the code in my code base or my dependencies that doesn't respect that? Because in that case, I guess that accessor would throw an exception, so I would probably find out at runtime.
I'm pretty sure the flag is already there. It's a little bit obscure,
but
it's there. What I don't remember is whether it's a production JVM option or a one that you can only get in a debug build. I'd have to look, but it's there. We've done experiments with it, and when you enable it, some code runs faster because constant folding.
Okay, but will it be? Are you making plans to make that the standard, the default, or the other way around, or are they?
No, we will eventually make that not only the default but the only way.
Oh, the only way, really?
Yeah.
Okay.
Post-production Nicolai here. I want to briefly interrupt the conversation to point out that since then, JDK Enhanced Proposal 500 was published. Its title is Prepare to Make Final Mean Final, and the summary says, issue warnings about uses of deep reflection to mutate final fields. These warnings aim to prepare developers for a future release that ensures integrity by default by restricting final field mutation, which will make Java programs safer and potentially faster. Application developers can avoid both current warnings and future restrictions by selectively enabling the ability to mutate final fields where essential. On a different note, since you're the kind of person who spends their free time listening to the deep lore of Java's development, you may also be interested in meeting the people behind the technology, like Mark, face to face, attend their talks, and have conversations with them about Java's past, present, and future. If so, there is no better place to do that than Java 1, which returns to the Bay Area in California, USA from March 17th to 19th, 2026. For more infos, check java1.com. I hope to meet you there. And now, back to the conversation.
Sounds like you should really just then set. What does set accessible even do anymore at that point? Oh, I know it still does things.
Yeah, it still does. I mean, set accessible will always be there, right? There are plenty of legitimate uses of reflection.
Yeah.
Right. You can have a module that opens some packages, opens all of its packages to a framework that's going to do reflection on it, and it might need to do set accessible. Fine.
Yeah, I think that's actually a good point. I think it's sometimes easy to slip into this mood where these things harm the further maintainability or development of Java, so they're bad. Or at least it comes across like that. But that's not the point, right? As I said, reflection, there's lots of legitimate use cases that nobody contests or argues against, just like dynamic agents are great and GenAI are great. Nobody says these technologies are bad just because you need a flag to enable them. It just means they come with a certain characteristic that you should willingly accept and not just accidentally roll with.
Right.
I have a question. Maybe it's helpful when people hear from the horse's mouth. In the past, we used to say JPMS for a while. Then a bunch of people said module system, me included. Now we're talking about modules. Can you give me your thinking about that so that we really have a good and succinct explanation for why we really try to establish the terminology modules more, or just give me your...
Right, so it was sort of an unfortunate accident of history.
Aren't most things.
Yes, indeed. That the term JPMS was ever even used. That is not, as we were working on Jigsaw ahead of 9, it was like a 8 or 9 year project. We never used that term, but I guess in the ecosystem by then there was a tradition of acronymizing everything, and when 9 was released, people started talking about JPMS, and at first we're like, what? Oh, modules. Oh, okay.
But you used the term Java Platform Module System, didn't you? Like somewhere, I don't think people came up with those letters on their own.
No, people did not come up with those letters on their own. The official title of the JSR and the JCP was Java Platform Module System.
Okay.
A name which was carefully chosen for historical and political reasons.
Well, because the other module system won't make clear which one this is about. Other module adjacent things.
Right.
Yeah.
Right. I think also unfortunate, though less unfortunate than JPMS. I mean, JPMS, it's an acronym when you don't need an acronym.
Mm-hmm.
Right. Did we have an acronym for lambdas? No, we didn't.
Yeah.
It's, I'm not sure how to put it any less delicately. It sounds like an unpleasant medical condition. It's just like, modules were, well.
It is fitting though that of all the abbreviations within Java, modules get the one that sounds like a medical condition. There is kind of.
But modules are a fundamental construct in the language.
Yeah.
Right, and that's also why the term module system is not a good one.
Mm-hmm.
Module system, it strongly suggests that what you've built is a large thing that sits on top of the JDK.
Yeah.
And somehow provides some modularity functionality.
Yeah.
Well, no, we don't have a class system.
Yeah.
In or on the JDK.
Yeah.
Right? We don't have a garbage collection system. We have garbage collectors.
Yeah.
So we have modules.
Yeah.
We didn't have a generic type system. It was just.
Well, we have a type system though.
We have a type system.
Yeah.
You can't avoid that terminology.
Interesting.
But
like,
anyway,
why is
they're just modules.
nobody ever thought about calling it the Lambda system, and so many people, me included, still tend towards module system, and I don't think that is entirely for historic reasons. I wonder whether there is some characteristic of these features that make us more inclined to call one of them a system. I can tell you how I was thinking about this. To me, modules were a bundle of information, like what it requires and what its APIs are and all that. And then the module system was the system on top of that, as you said, that handles this information and makes the right things happen, that selects the dependencies, that looks at the module path, and that puts all of this behavior together. So in that view, modules are like a somewhat or mostly passive carrier of information, and that's about it. But when you remove the phrasing module system and you only talk about modules, then they suddenly become active parts that do things, that they protect their internals, they select their dependencies. And so that's just a different way to think about, clearly the same technology.
Yeah, but there's a very similar situation with classes, right?
Yeah.
A class file in the file system
I'm agreeing with you.
Just a class file, and then we have class loaders. We don't talk about a class system.
Yeah. And classes is maybe just like classes, packages, modules. Why would I have the inclination to say module system when I never ever thought about package system?
There is an abstraction called module loader in the JDK because you need to load modules just like you need to load classes.
Okay, I'll try. I promise you in the past, I really try. It's not easy to go.
You can do it. Be strong.
I had to go like years of phrasing. But yeah. Okay, so at the top of this, you mentioned stewardship and integrity is something you want to bring us more insights into. Is there more in that realm? I think did we cover it? I'm basically arguing. Do you want to make any closing statements or?
No, I think we kind of told a story here. We've talked about sort of some of the history of Java stewardship, and stewardship in the early days meant retaining internal APIs even if you didn't want to, and stewardship eventually led to to creating modules and having boundaries and gradually introducing restrictions so that people wouldn't be broken too quickly. And yeah, I think that's about it.
Nice. Okay. That also means though that at some point this travel towards integrity by default, where you get new command line options, you have this feeling of this used to be work immediately. Now I have that this option. At some point we're past that, right? At some point this journey is over. We have integrity by default. Every new feature that potentially undermines it will come with a flag to guard it.
Yep.
And from that moment on, this mental process of getting used to this new world is gone. It's done. We're just, that's the new statement. Yeah, I think that's a worthwhile goal. Thank you very much, Mark, for spending this time with us and sharing this information. And yeah, everybody, I don't know, do I have to do the YouTube thing where you have to like and subscribe and leave comments or whatever? I don't know. You know what to do. We'll definitely read the comments, and if there are some good questions, maybe I'll, back channel them to Mark and get you some answers. And have a good one, everybody. Bye.